Good afternoon. This is Professor David J. De Los Reyes. My topic this afternoon will be a new topic on my channel under the course Differential Equation. I am now on, what do you call this, topic number, okay, I will try to see. This is topic number 26 already on the subject matter differential equation on my channel, because I am through with differential calculus. I am through with integral calculus, and this is the third course differential equation, and I am on topic number 26. So this is designated DE26, meaning differential equation, lesson number 26. And the title of the topic is actually, it falls under differential equation, but the subtopic is Bernoulli's equation. Under differential equation, I am now through with the variable separable. I am now through with the so-called homogeneous differential equation, the solutions. I am now through with differential equations that could be solved by using integrating factor. And the fourth type of first order differential equation, that is our topic for this afternoon, is Bernoulli's equation. Okay, let's proceed. This is just plain concept. Before I will go with the example problem on the evaluation, I will try to discuss the concepts on how to solve a Bernoulli's equation under case number 1 and case number 2. Because Bernoulli's equation is actually related to the solution of a problem that involves integrating factor. Okay, I will try to discuss the concept. For case number 1 under Bernoulli's equation, Bernoulli's is actually, I think, it's a family name of a scientist that is involved in physics. That's why it is a Bernoulli's equation. He got an equation. Case number 1 will be dy dx, that is plus p of x times y equal to q of x. For it to fall under Bernoulli's equation, it got this term here, times y to the n. Because under the previous discussion, that is a differential equation that could be solved by using integrating factor, this is missing. The y to the n is not present. It is just simply this, dy dx plus p of x times y equal to q of x. That is solvable by using integrating factor immediately. But if there is a factor y to the n as an added thing, it falls under Bernoulli's equation. That is case number 1. For case number 2, it's just the reverse of the first one. It is dx over dy plus r as a function of y times x equal to s as a function of y. For case number 2, instead of y to the n, this is x to the n. And under case number 2, under the so-called integrating factor, this term is missing. This x to the n is missing. The one I cover. It is just simply dx over dy plus r of y times x equal to s of y. If the one covered is missing, it will be solvable by using the integrating factor immediately. But if there is a term x to the n, it falls under case number 2 for Bernoulli's equation. Okay? Okay, let's try to bring out the solution. I just checked my camera. This is y to the n for case number 1. This is x to the n for case number 2. Where n is any constant, there's a limitation for the value of n, except 0 and 1. Because if n is 0, this will become y to the 0, and y to the 0 will be 1. So it falls under integrating factor solution immediately. So for it to fall under Bernoulli's equation, there's a limit for the value of n. It will not be equal to 0, and it will not be 1. Okay? Same as for case number 2 also. N will not be 0 and 1. Okay? And the required substitution for case number 1, we introduce a third variable z equal to y raised to 1 minus n. So whatever n that comes out here, you put it here, and you needed the substitution to be put back in the original differential equation, plus the value of dy in y, also back to the original equation, and for the resulting equation to be solvable. And according to our note, after the substitution of z, dy and y back to the original Bernoulli's equation, and after simplification, this resulting solution is by using an integrating factor. You got that, guys? Meaning to say that after the substitution of the value of z, dy and y back to the given Bernoulli's equation, what will come out will be a differential equation that is solvable by using integrating factor. That's why before we discuss Bernoulli's equation, we discuss first the solution of a differential equation solvable by using integrating factor. Because without knowing that one, you cannot solve this problem. So the requirement for a Bernoulli's equation is that you should know how to evaluate a differential equation that could be solved by using an integrating factor. Oh, that is case number 1. For case number 2, it's the same. It's just the reverse of the first one. Because this is x and this is y. Okay? The required substitution is also a third variable z. This is x, right? So this is equal to x raised to 1 minus n. So whatever value in here, you put it here. And that is equal to z. Then from the resulting relation, try to compute for dx and the value of x. So we substitute the value of z and dx and x back to the given Bernoulli's equation, okay? Then after the simplification, okay, what will come out will now be a differential equation solvable by using an integrating factor. So the requirement is that you should know how to solve a differential equation solvable by using an integrating factor. That was our last topic. This is our fourth topic under the differential equation, because we are now done with the variable separable, homogeneous, using integrating factor. The fourth one is Bernoulli's equation, and the requirement for Bernoulli's equation is that you should know how to evaluate a solution using integrating factor. Okay, that's it, guys. The concepts of differential equation under Bernoulli's equation. Case number 1, case number 2. Because if I will try to cover this one, it falls under integrating factor, case number 1. If I will try to cover x to the n here, okay, it falls under case number 2, under integrating factor. But since case number 1 is with the term y to the n, it falls under Bernoulli's equation. And you needed this substitution here, z dy y in here for it to be solvable. For case number 2, you should need the value of z, dx and x, put it in the original differential equation, Bernoulli's equation, for it to be solvable by using an integrating factor. Okay, that's it, guys. The concept on the solution of a differential equation under Bernoulli's equation. Case number 1 and case number 2. My next topic on my channel will be an example problem, illustrative evaluation of a Bernoulli's equation. So you could visualize the concept on how to bring out the solution. Good afternoon, Los Angeles. For those who are taking up differential equation, this is for you guys. Good afternoon, Los Angeles.